Okay, now we're doing the second part of this handout, H10J.2, second derivative. This problem number 5 is a little tricky, so uh, let's get started. Okay, so consider we've got some curve and we have no idea what it is, and we've got P and Q are constants. So basically what we have f of x equals px squared plus qx. Okay. Point 1, comma 3 lies on the curve, and the tangent to the curve at point A has a slope of 8. Okay, so if I take the derivative of this, I get 2px plus q by taking the derivative, and we just were told that the derivative is going to be 8. Okay, so we're going to need to get two equations. So here's one of my equations. The other thing, using this equation, we've got f of x equals px squared plus qx, right? And we know that when x is 1, that y is going to be 3. So I'm going to replace f of x with 3, and I'm going to replace x with 1. Okay? So I replaced x with 1, and I replaced f of x with 3. So now I've got two equations and two unknowns. So using these, I can figure out what p and q are going to be. So just going to rewrite this one here. 2 oh, what did I do wrong? At this point, the slope is 1. So we replaced that with 1. This x should have been 1. Because x is 1 when the slope is 8. Okay. Alright, so now I've got 2p plus q equals 8, and I've got p plus q equals 3. If I subtract both sides, I can use elimination. To help us find q. So 2p minus p is going to give me p. Q minus q is going to make that go away. And 8 minus 3 is going to give me 5. So now I know p is 5. So let's use this other equation. 3p plus q. Okay, so using equation 2, this is equation 1, this is equation 2, right? I'm going to replace p with 3. Oh, wait, with 3. I can't even count. 8 minus 3 is 5. Okay, so I'm going to replace p with 5. So now I've got 3 equals 5 plus q. And then if I subtract 5 on both sides, I end up with q equals negative 2. So my new equation is f of x equals 5x squared minus 2x. This was a really fun problem. I know you are so excited. The following diagram shows graphs by displacement, velocity, and acceleration moving da da da. Okay, so complete the following table by noting which A, B, and C corresponds to which function. So displacement is where a thing is located, so that's f of x. Velocity is the first derivative, and acceleration is the second derivative. Okay, so the first derivative is going to have to be, the function is going to have to be the one with a minimum and a maximum. Okay, so that's graph A. The velocity, if I take the derivative of something that has that, it's going to have just a single curve, and that's going to be B. And thirdly, our acceleration is going to have to be, oh wait, I messed up with this lettering, didn't I? This blue one is graph C. Oopsies. And the orange one here is graph B. Okay. Write down the value of t when the velocity is greatest. The velocity is greatest when the first derivative is greatest. Right? And the first derivative is greatest when t equals 3. Okay. Next page. Okay. The diagram shows part of the graph, and this is the graph of the first derivative. Okay, this is the graph of the first derivative. And A and C, we've got points in C. B is a minimum, D is a maximum. Write down the value of F prime. This is F prime. Okay. It's hard to see that. It's drawn. So the F prime at this spot is 0. Okay. Hence, show that C corresponds with the minimum of the graph. So this graph is the first derivative, and that represents slope, right? So at C, we have negative values, and to the right we have positive values. So if my slope is going down and then up, we've got a negative. And a sign diagram is enough on an IB test to show and explain. Okay. So that makes it a minimum. Okay, to the left is negative of C, and to the right the slope is positive. Okay. Which of the following A, B, or D corresponds to the maximum of the graph? Okay, so the maximum, let's do a sign diagram. So A, B, C, D. So this is the first derivative graph. So we have positive values here. We have negative values between A and B. We have negative values between B and C. We have positive values between there. So which represents a maximum? The maximum, once again, is when the first derivative is equal to 0. Oops. Right. So we want the first derivative equal to 0. Well, we know the first derivative is equal to 0 at C, right? So the maximum is probably going to be there. But let's look at slope, just because if we have a positive slope and then we have a negative slope, that's going to give us a maximum. So we know the maximum happens at A. Okay. It's tricky because this graph is the first derivative. Okay, that's we're so used to looking at the original function, not the graph of the derivative. Show that B corresponds with the inflection point. Okay, so if I do a sign diagram with the second derivative, we know at B we have this. So the second derivative is the slope of the first derivative. So here we have a negative value, and here we have a positive value. And right at B, the slope of the derivative function is 0. So at B, slope is 0. Therefore, the second derivative is equal to 0. Because the second derivative has to do with the slope of the first derivative from this graph. Okay, 8. Here's the function of g of x. Find the two values of x at which the tangent of the graph is horizontal. Okay, so if the tangent is horizontal, that means the derivative is 0. Okay, so the derivative is going to be 0. So let's take the derivative here. Okay, so g prime of x is 3x squared minus 6x minus 9. Okay, I can factor out a 3, and we get 3x squared minus 2x minus 3. And this factors out to be 3 and 1. And this one's negative, and that's positive. So now I know that x equals 3 and x equals negative 1. And these are the two values that have a tangent that's horizontal. Okay. For each of these values, determine whether it is a minimum or a maximum. So let's do a sign diagram of the derivative. Okay. So we know something happens at negative 1. We know something that happens at 3. If I plug in something smaller like negative 2, if I plug a negative 2 in here, I have a negative and then times a negative. So positive times a negative is going to give me a positive value. So we have a positive slope. If I plug in something between -1 and 3, like how about 0? If I plug in 0 in here, I have -3 times +1. So negative times a positive is going to give me a negative value. The slope is down. Okay. If I plug in something random greater than 3, let's pick 4. Okay, so 4 minus 3, that's positive. 4 plus 1 is positive. So positive times positive is going to give me positive. We have a positive slope. So which of these values is the maximum or minimum? So we know at um, at x equals -1, we have a maximum. Okay. At x equals 3, it's a minimum. Right, because the slope goes from a negative slope to a positive slope. That's a minimum. Okay. Okay, the following diagram shows the graph of the quadratic equation. Okay, so write down the values of P and Q. P is 1 and Q is 5. Okay, write the equation of the axis of symmetry. So the axis of symmetry is halfway in between, and so we would say x equals 3. Because it's an equation, it has to have an equal sign. So no credit if you don't write an equal. Okay? No credit without x equals. You have to have the x equals here. Okay, find the equation in this form. Well, we know our vertex is 3, comma, -4. And in vertex form, we have y equals, and for a vertex, this is h, comma, k. Okay, so I would have x minus 3 squared plus -4. Okay, and like I said, this is in vertex form. We didn't do a whole lot in vertex form. We used to do that a lot in vertex form before the pandemic. But okay, so x minus 3 squared simplifies to x squared minus 6x plus 9. And then this simplifies here to y equals x squared minus 6x plus 5. Let me know if you have a little difficulty with this. Okay, so now I want to find the derivative of this, and I get derivative is equal to 2x minus 6. Okay, let t be the tangent of the curve at 0, comma 5. Find this equation. Okay, so the first thing we need to do is find the slope. So to find the slope at x equals 0. So to find the slope at x equals 0, I'm going to plug in 0 in for 2. So we know that our slope is -6. Okay, so y minus y1 equals mx minus x1. Okay, I'm going to replace the slope with -6. Replace y1 with 5. Replace x1 with 0. Then I get y minus 5 equals -6x. add 5 on both sides, y equals negative 6x plus 5. Okay, next questions. Okay, the diagram below shows the graph of the first derivative. So, if I want to take the second derivative looking at this graph, we know that it's 0 at q, and I've got um, the x-intercepts at q. And here it's positive. And our graph's going to be like that. Because we have an inflection point at q. Since the second derivative is 0, it's an inflection point. Okay, when is the minimum? So we need to do a sign diagram here. Okay, P, Q, R. Okay, the minimum point happens. So looking at the first derivative, we know we've got a negative slope, then we have a positive slope, we have a positive slope, and then we have a negative slope. So if it goes from negative slope to positive slope, we're going to have a minimum at P. If we have a positive slope and we still have a positive slope, we have an inflection point at Q. If we have a positive slope and then a negative slope, we have a maximum at R. Okay, so this inflection point happens when on either side it goes positive and positive. Okay. Okay, let's keep moving. Okay. Let's use this one here. Okay, so our derivative is negative and then positive and then negative. So if we've got a negative slope and then a positive slope and then a negative slope, at 0 we're going to have a minimum, and if we go from a positive slope to a negative slope, then we're going to have a maximum at this point at negative 2 and at 1. Okay. If my second derivative is positive, we have concave up. And if the second derivative is negative, we have concave down. Okay. Using this information above, write down the value of x when g is at a maximum. It's at when x is 1. Okay. And justify your answer. You don't just write the answer down, justify it. So, because the first derivative goes positive to negative. When you go from positive to negative, it's going to be a maximum. Okay, on which interval is g decreasing? G decreases when the second derivative is negative. So it's decreasing between -3 and -2, and between 1 and 3. Negative, negative. Okay. Write down the value of x of the graph that has an inflection point. The inflection point happens when it changes from concave up to concave down. So x equals -1/2, and because the second derivative equals 0. Okay. Given g of -3 is 1, sketch the graph the best you can. Okay, so -1, -2, -3, 1, 2, 3. Okay, -1/2. Okay, so at -1/2, we know we have an inflection point. So we've got a minimum at -2. We've got a maximum at 1. Okay, so, and we have an inflection point at 1/2. Okay, and at -3 we're at 1, so we've got a point there. -3, 1. Okay. Okay, our minimum's at -2, our maximum is x is 1, inflection point at 1/2. These dots can be anywhere as long as they're in those spaces. And now let's draw a line. I'll try in red. Okay. Oh. So I guess that's supposed to end there, but whatever. Okay, so at this point, at our inflection point, it's concave up from here to here. And then from here to here, greater than 1/2, it's concave down. Between -3 and 2, our slope our derivative is negative. Okay. Okay, I hope that helps. Okay, next one. Okay, so we've got at 0, 1, we've got a point, and at 1, 2, we've got a point. Okay, so between -2 and 1, we've got a negative slope, and this, remember, this has to do with concave, and this has to do with slope. Okay, so this is concave up, and this is concave down. Okay, when the second derivative is 0, we've got an inflection point. Okay. So between -2 and 0, we're going down in general. And between -1 and everything else, we have a positive slope. Okay. So we go down until we get to 0, -1, and everything above is higher. Now let's look at slopes. So I just drew this really lightly to determine what we're doing. Okay, so we have positive, positive, positive until here. So this means we have concave up, and from here to here we have concave up. It looks like a cup. And then we have our inflection point, and now it's concave down. So looks like we're dumping water out of that part. Okay, so between here and here, this blue part looks like a sad face, and our positive values here, this looks like a smiley face. Whee! Okay. And I'll do the next part in part 3.